the race for artificial intelligence is entering an entirely new era. Around Gigafactory, Texas, heavy construction equipment is reportedly preparing the site for what could become one of Elon Musk's most ambitious projects yet, a next-generation semiconductor facility with an estimated value of $25 billion. If Tesla simply needed more chips for the Model Y or Cybertruck, the solution would be simple. Musk could place larger orders with companies like Samsung, TSMC, or Nvidia and wait for delivery. But Tesla's challenge has become much bigger. The company is no longer building only electric vehicles. It's developing self-driving cars, humanoid robots, AI supercomputers, satellites, and autonomous transportation systems. Every one of those technologies depends on enormous amounts of advanced computing power. If computing power becomes the most valuable resource of the AI era, Musk appears determined to secure his own supply rather than relying entirely on outside manufacturers. That's the vision behind Terafab. So how could this proposed $25 billion project reshape the technology industry? The bigger question isn't the cost of the factory. It's what happens if Tesla, SpaceX, and XAI eventually require more advanced chips than today's semiconductor industry can realistically produce. Modern AI runs on chips. Self-driving cars process camera feeds and make driving decisions in real time. Humanoid robots rely on AI processors to understand their surroundings and perform physical tasks. Starlink satellites need specialized processors for communication, while AI data centers require enormous computing power to train increasingly capable models. Whoever controls advanced chip production could ultimately control the pace of AI development. That's why Terafab may be one of Elon Musk's boldest strategic moves. Rather than depending entirely on global suppliers, Tesla appears to be working toward greater control over one of the world's most important technologies. If successful, the company could move beyond the automotive industry and compete alongside semiconductor leaders such as TSMC, Samsung, and Intel. According to Elon Musk, Terafab is envisioned as a massive chip manufacturing complex with the long-term goal of reaching 1 terawatt of computing capacity annually, illustrating just how ambitious the project could become. If each AI processor consumes roughly 250 watts, reaching that goal would require producing billions of chips every year. At that point, Tesla would no longer operate only as an automaker. It would become part of the world's semiconductor infrastructure. Terafab could also expand to nearly 100 million square feet, making it one of the largest semiconductor campuses ever envisioned. Tesla itself has also changed dramatically. What was once an electric vehicle company has evolved into an AI company developing robotaxi, cybercab, Optimus, and intelligent software capable of operating in the real world. That shift has transformed semiconductor demand into one of Tesla's highest priorities. Self-driving vehicles and Optimus robots require specialized AI processors capable of handling enormous amounts of real-time data while remaining efficient and reliable. As Tesla expands both platforms, chip demand could increase dramatically. Terafab also isn't intended to support Tesla alone. The project is expected to benefit Tesla, SpaceX, and XAI. For SpaceX, future satellites may eventually process AI directly in orbit, requiring radiation-resistant processors capable of operating in the harsh environment of space. Meanwhile, XAI's rapidly growing language models require enormous computing resources, potentially consuming even more AI chips than Tesla and SpaceX combined. As all three companies continue expanding, semiconductor demand could rise far faster than current manufacturing capacity. That's why Musk's challenge is no longer simply finding suppliers. The bigger challenge is ensuring enough chips exist to support the future of his entire ecosystem. Tesla has followed a similar strategy before. When battery technology became increasingly important, The company partnered with experienced manufacturers, gained expertise, and eventually developed its own 4680 battery program. Terafab appears to follow the same philosophy, but in an industry that's even more demanding. Building advanced semiconductor fabs is among the most difficult manufacturing challenges in the world. It requires ultra-clean facilities, advanced lithography systems, specialized materials, sophisticated manufacturing techniques, and years of experience. Even microscopic defects can ruin entire batches of silicon wafers. That's why many experts believe Tesla cannot accomplish this entirely on its own. Reports suggest Terafab could benefit from partnerships with experienced semiconductor companies, allowing Tesla to gradually expand its manufacturing capabilities while continuing to design its own custom AI processors. Intel's decades of semiconductor manufacturing experience could significantly reduce Tesla's learning curve, making Terafab a more realistic long-term project. Ultimately, this project isn't simply about building another giant factory. It's about securing one of the most important resources of the AI era. Without enough advanced chips, Tesla's robotaxi network, Optimus program, and future AI products could all face significant delays. The same applies to XAI, where increasingly powerful language models demand massive amounts of computing hardware. SpaceX also depends on advanced processors for future satellite networks and space-based computing systems. Rather than waiting for suppliers, Musk appears determined to build greater control over the technology that powers all of his companies. Can Tesla actually build one of the world's most advanced semiconductor manufacturing facilities, despite having little direct foundry experience? Many analysts remain skeptical. Instead of replacing established manufacturers overnight, Tesla will likely begin by designing custom processors, building prototypes, and gradually expanding manufacturing over time. According to Musk's vision, Terafab could eventually produce two main categories of processors. The first would power Tesla's full self-driving platform, robotaxi fleet, Optimus robots, and future AI products. The second would focus on space-grade processors designed for SpaceX, capable of surviving radiation, extreme temperatures, and the harsh conditions of orbit. Locating Terafab near Giga Texas also offers another advantage. Prototype chips can be tested directly inside Tesla vehicles, Optimus robots, factory equipment, and AI systems, dramatically shortening development cycles and allowing engineers to improve designs much faster. More than lowering costs, Terafab gives Tesla greater control over chip design, production schedules, software integration, and future AI innovation. Apple demonstrated the value of designing its own processors with Apple Silicon. Tesla hopes to achieve something similar, but across self-driving vehicles, humanoid robots, AI infrastructure, and space technology. Even so, enormous challenges remain. Building a semiconductor ecosystem approaching 100 million square feet would require vast amounts of land, electricity, water, specialized equipment, skilled engineers, and years of continuous development. That's why many observers believe the facilities near Giga Texas represent only the beginning of a much longer journey. Whether Terafab ultimately achieves Musk's ambitious vision remains uncertain. But one thing is becoming increasingly clear. The future of artificial intelligence won't be determined by software alone. It will also depend on who controls the computing hardware powering tomorrow's AI systems. If Tesla succeeds, it could reduce its dependence on outside suppliers while strengthening its position in autonomous driving, robotics, satellites, and artificial intelligence. Terafab may ultimately become one of Elon Musk's biggest bets and one of the most important technology projects of the decade. What do you think? Could Terafab become Tesla's next revolutionary breakthrough, or is the project simply too ambitious? Let us know your thoughts in the comments below. If you enjoyed this analysis, don't forget to like the video, subscribe to the channel, and turn on notifications so you never miss our latest updates on Tesla, artificial intelligence, robotics, and the future of technology. Thanks for watching, and we'll see you in the next video.